Well, thanks for having me here. Animal agriculture, which is the technology for producing food from animals, is going to be essentially gone from the world within 2 decades. And in the next 20 minutes or so, I will trace my own experience of learning first why it must happen and then how it will happen. For most of my adult life, I was a tenured professor at Stanford, and it was the best job in the world. I had great funding from Howard Hughes Medical Institute, among others, and my job, I'm not kidding, was to follow my curiosity wherever it took me, invent things, discover things, and mentor amazing students. So if that's not a dream job, I don't know what is. About 12 years ago on a sabbatical, I set myself the challenge to figure out what's the most important problem in the world that I can contribute to solving. And I'll take you through how I came to the answer to that. So most of you probably already know that nature's in trouble around the world. But I think many people don't realize how bad it's getting and how fast it's deteriorating. This is a chart that was taken from a publication by a consortium of scientists that started more than 50 years ago, and basically they started out by identifying a set of a little over 5,000 mammal, bird, reptile, and amphibian species, and then effectively taking a population census of those species periodically over the next 50 years. And what they reported recently is that across this whole, and those species were intended to kind of sample the diversity of vertebrate life on Earth. And what they reported recently is that on average, those populations today are less than a third what they were 50 years ago when I was a kid. And that trend shows no sign of stopping. And more recently, there have been a number of studies that have reported a similar thing for insects. This is one of them. The New York Times called this the insect apocalypse. Basically, if anything, around the world, flying insect populations seem to be crashing even more rapidly than vertebrate populations. And that's a great thing if all you care about is a cleaner windshield. But it's a terrible thing when you consider that 80% of all the flowering plants on Earth depend on insects for pollination, for reproduction, basically. And 70% of crops do as well. So this decline of animal biodiversity is, you can think of it as a leading indicator of what's going to happen with whole ecosystems and with plant biodiversity, because the animal species that are critical to keeping those ecosystems going, propagating them, enabling them to adapt, when they disappear, that robustness goes with it, and this is what's coming. Okay. What does this have to do with animal agriculture? Well, basically, the shorter answer is the overwhelmingly primary driver of the global collapse of biodiversity is animal agriculture, at least on land. This is just one little snapshot of give you an idea of how insane it's gotten. Right now, there are 1.7 billion cows living on Earth. Those cows, their total mass of those cows exceeds by more than a factor of 10 the combined mass of every remaining terrestrial mammal, bird, reptile, and amphibian on Earth. We've essentially almost entirely replaced nature with cows. If you see an animal anywhere in the world, most likely it's a cow. And the main area where animal agriculture and biodiversity collide is land use. So the International Livestock Research Institute, Better Lives Through Livestock is their motto, reported a number of years ago that the land footprint of animal agriculture covers 45% of the ice-free surface of Earth. That's an area that's bigger than the total area of North America, South America, Europe, and Australia combined, actively being used, raising animals for food. And to make that possible, the native ecosystems, forests and shrublands and grasslands were cleared for grazing and feed crops for livestock. For comparison, all the crops that are grown for food that humans directly eat fit on about 8% of Earth's land area, and every city and suburb on Earth sits on less than 1.5% of Earth's land area. So more than 80% of the entire land footprint of humanity on nature is animal agriculture. Okay. Quick segue on climate. As probably most of you know, we're on a pretty bad trajectory with respect to climate and global heating. We're way off track relative to the commitments that were set in Paris a decade ago. And at this point, the only way that we're going to be able to avoid disaster from global heating is by unlocking negative emissions on an enormous scale. Okay, that's all been the bad news. Now here's the good news. The thing that initially got me going was the realization that's sort of illustrated in this graph. And this graph was taken from a paper that I published with a colleague of mine at Berkeley, Mike Eisen, last year. And basically what it shows is at the top, the solid line represents the trajectory. So the y-axis is basically the amount of heat that's excess heat that's being delivered to Earth. And the solid line represents the trajectory we're on today. The dashed line represents the trajectory we could be on if we could phase out animal agriculture over the next 15 years, suspend disbelief. And this was based on just using data from authoritative sources like IPCC and NASA and NOAA and the UN Food and Agriculture Organization, and just modeling it out. I'll quickly take you through how it's accomplished. The three different color sectors represent the three major ways in which phasing out animal agriculture unlocks massive negative emissions. The green sector represents biomass recovery on the land from which biomass and ecosystems have been cleared to make room for animal agriculture. And the amount of carbon that was released into that process is equivalent to about 22 years worth of fossil fuel emissions at the current rate. 22 years worth of this year's fossil fuel emissions. Unlike fossil fuel emissions, though, the emissions from biomass, from clearing biomass, are completely reversible using the most mature carbon capture technology on Earth, optimized over 3 billion years of evolution, and that's photosynthesis, which turns carbon dioxide back into plant biomass. The other two colors represent methane and nitrous oxide, which are major greenhouse gases for which animal agriculture is one of, or the most, the major source. And the thing about those gases, unlike carbon dioxide, is that they are chemically unstable. They decay spontaneously, which basically means that unlike CO2, once you pump into the atmosphere, it's there pretty much for thousands of years unless you can pull it out. Methane and nitrous oxide decay spontaneously. So once you stop those emissions, you get negative emissions right away. And that's how phasing out animal agriculture can accomplish something that no one had considered possible. It's quite amazing that within a little over a decade, it would take us to a 30-year period of net zero emissions, where the negative emissions from that phase out actually slightly more than counterbalance all the ongoing emissions from all other sources. And through the end of the century, these negative emissions would offset more than half of all the projected greenhouse gas emissions, assuming we stay on our current trajectory, which let's hope not. Okay, but what about diet? What about nutrition? Despite the relentless propaganda from the slaughter cartel trying to convince people that there are essential nutrients that you can only get from from meat or animal foods, all the scientific literature says that's bunk. And this is just a paper from 12 years ago, but basically the consensus and all the evidence says that there are no essential nutrients that you can only get from animal products. And in fact, a diet consisting entirely of plant products is healthy at every stage of life, from infancy through old age, including pregnancy, and if anything, healthier than standard omnivorous diet. So there's that. And then you might wonder, okay, what about global food security? How are we going to meet the world's nutritional needs, without animals? Well, it turns out that animal agriculture is a net negative in terms of nutritional productivity. The crops currently grown on Earth contain more calories, more protein, and more of every essential amino acid and micronutrient than all the meat produced globally. In fact, more than enough to meet all the nutritional needs, not just of the 8 billion people who currently live on Earth, but the 10 billion people that we expect to be on Earth in 2050. Just this year's plant crops. And in fact, this year's global soybean crop, interesting statistic, contains 2.5 times as much high quality protein as all the meat produced globally. And that crop alone has more protein and more of every essential amino acid than required to meet the protein needs of everyone on Earth today. Okay, so. Well, this convinced me, okay, this is the problem that I need to work on. We need to figure out a way to phase out animal agriculture ASAP. And it's a hard problem. It's like, okay, now we're at the stage of we have to imagine solutions, so to speak, if I can use that term. And there are some things that we can pretty much rule out. So we're not going to solve the problem by trying to persuade people to change their diets, okay? More than, the vast majority of the world's population considers meat not just an essential source of nutrition, but one of the major sources of pleasure in their daily life. So don't waste your time trying to tell them to stop. And and governments aren't going to be able to solve this problem by regulation, because any government that tries to tell people what they can and can't eat, or farmers what they can and can't grow, is going to be out of office the next day. But fortunately, innovation can solve this problem. And the good thing about it is that fundamentally it's a technology problem. The problem isn't that people love to eat meat. The problem is we're making it the wrong way. We're using the wrong technology to produce it. So, for many thousands of years, we've relied for all kinds of technologies, basically all kinds of applications. The core technology has been animals. For power transportation, even for mobile communications. The state of the art from 600 BC until after World War I was carrier pigeons, okay? But those animals became obsolete as a technology. But in the food system, we haven't gotten there yet. But the cow is a sitting duck for better technology. It's incredibly low performing by any measure, including economics and any measure of efficiency and so forth. So, so that's how we need to approach solving it. The science has had a central role in our food system since prehistoric times. Pretty much all the foods that you recognize today were discovered through a process of thousands of years of scientific research, basically exploring and testing and experimenting from thousands of plant and animal and fungal sources of potential nutrition to figure out which ones are safe to eat, which ones have good nutrition, which ones are palatable, and then figure out how to process them to make them optimally palatable and healthy as foods. This illustration is two indigenous Amazonians preparing cassava. And the story of cassava is that 8,000 years ago, actually, people in the Amazon somehow discovered that this root, which is deadly toxic if eaten in its native state, basically, it contains lethal levels of cyanide, that if you go through this process of mushing it into small pieces, extensively washing it with water, and then cooking it, it becomes a great source of calories and nutrition and highly palatable. And in fact, this is one of the staple crops worldwide, one of the major sources of calories now. Okay. Well, that process of science adapting the food system to changing demands and changing conditions and changing needs is still ongoing. And so when I decided to take on this problem, basically I founded a company called Impossible Foods. Unfortunately, it was easy to get investors to invest in it because if you say, it doesn't matter all the stuff about the science, if you say, basically we're going to replace a $2 trillion global industry, they reach for their checkbooks. So what we did starting out was first we assembled, the most important thing was we assembled the most talented, motivated, innovative group of scientists who ever worked on food. And this is that amazing group of people. It's Halloween. Then they set out to understand the molecular mechanism. They studied meat basically the way that in my past life I would study a disease. Understand the molecular mechanism so you can be very deliberate in figuring out how to solve it. They studied the molecular mechanisms, particularly of the sensory experiences of meat from animals. Then figure out how to recreate that experience without using animals, using sustainable, scalable ingredients from plants or microbes. And then make it better than the animal version, which you have to do if you're going to replace the incumbent technology in the marketplace. Okay. So this is just one example of the work that went into this. Obviously, there's a lot more than this. But one of the obvious questions is, and that we didn't know the answer to when we started out, why does meat taste like meat? Why is it that you can immediately recognize meat, any kind of meat, as not being a vegetable, not from a plant, when you taste it? Why is it, when you cook broccoli, it gets mushy and warm, and when you cook meat, you get this explosion of flavor and aroma that you never get from cooking plant? Well, as a biochemist, to me, this sounded like there's probably a catalyst involved. And there was a very strong prime candidate, which is a molecule called heme. Heme is the molecule that carries oxygen in your blood. It's what makes your blood red. It's what makes meat red. It's what gives your cheeks their rosy glow. So you see it every day. But what's not as widely known is it's one of the best catalysts in nature, making chemical reactions happen that wouldn't otherwise. So if you take a solution of the simple nutrients that you can find in every cell, including plant cells, and you make a broth of that and you cook it, what do you get? You get something kind of blah. You get something mildly savory. It's sort of like weak miso soup or vegetable broth. But throw in heme into that mix, and magic happens. You get an explosion of meaty flavors and aromas from the same simple nutrients that otherwise are just like miso soup. And so that was one important discovery. Heme is sort of the magic ingredient that makes meat taste like meat and not like plants. There was obviously a lot more stuff we needed to figure out. We needed to figure out how to scale the heme production. We needed to figure out about texture and juiciness and mouthfeel and supply chain and stuff like that. But anyway, at the end of that, at some point, we had to say, okay, well, none of this matters if a meat consumer isn't going to choose it over the animal product, because that's the whole point. So let's see how that went. So the first product that we produced was basically raw ground beef made from plants. And one of the consumer tests we did was called an in-home use test. We give it to a bunch of mainstream meat consumers, and we asked them to use it all the ways they would use ground beef ordinarily, and then asked them what they thought of it. And 2/3 of these mainstream meat consumers rated it as good or better than ground beef from a cow that they'd been using all their lives. The nutrition is better, lower calorie, lower fat, zero cholesterol, same protein, higher iron, et cetera, and it's vastly superior in terms of environmental impact, which consumers don't really care about. But deliciousness is the main thing that matters. That's why we focused on it, and nutrition. Okay, what about pork, the most popular meat on earth? The pork that we developed in a blind taste test that was carried out in Hong Kong, where pork is the dominant meat with meat consumers, the pork made from plants in a blind taste test was preferred by a decisive majority of those Hong Kong meat eaters. And the nutrition is no contest. 37% lower calories, lower saturated fat, no cholesterol, et cetera, et cetera, et cetera. Okay. Same deal with chicken. Chicken made from plants in a blind taste test with thousands of mainstream meat consumers, 70% of them preferred it on taste alone over the best-selling food service and retail chicken nuggets. And again, the nutritional profile is superior. 40% less saturated fat, less sodium, and so forth. Okay. But that's just like data. What about anecdotes? Okay. So let's ask this guy, Glenn Beck, who's a notorious, for some people, right-wing radio personality and author who's also has a cattle ranch in Texas. So what does he think of it? This is a blind taste test prank played on him by his producer.
We have an A and B taste test. One is a real burger, one is an Impossible Burger. Can you tell the difference?
So A definitely tastes like meat.
All right, so now I'm going to try B. B is the fake burger.
Mm-hmm. I agree.
B is the real burger, A is the Impossible Burger.
That is insane.
That's amazing.
I'm shocked that both of you went with the wrong
That
one.
is amazing.
That's wrong. That's wrong to do that to me.
That
I
really
could
is
go vegan.
crazy. I could go vegan. You're anti-vegan stuff, where we
amazing.
both hate vegetables.
Yes.
Uh-huh.
And for that to fool, and I'm a rancher.
Okay, so so here's the deal. So we're at the cusp of a meat revolution. Everything in the past that's intended to be a substitute for meat has been a really sad imitation that no meat lover would take seriously. But now that a scientific approach is being taken to it, and since Impossible was founded, there are now dozens and dozens of new startups that are taking a scientific approach to replacing animals in the food system and so forth. And the technology that we've developed now, it's getting better every day. More delicious, healthier, more sustainable, lower cost, and so forth. And that's what happens with new technology. You might say, well, how could this possibly happen in 2 decades, though? That seems absurd. Well, actually, that happens all the time. A good recent example is the mobile phone, the digital camera. The first digital camera cost $1,000. It held 8 pictures, and they were 300,000 pixels. Okay, it was terrible. 8 years later, Kodak was bankrupt, and the only place that you could find a film camera anymore is an antique store. Okay, so when a technology comes along that does a better job of serving what consumers want, it can replace a dominant technology fast. Okay, last thing, and I'll be quick. What about the ranchers and farmers? Isn't this going to be a disaster for them? Actually, no. In fact, I think it could be a boon for them, and they could be our best allies, actually, in accelerating this. And here's why. Look at beef farmers and ranchers, okay? According to the USDA Census of Agriculture, the average profit per acre from beef ranching was $7 per acre per year. Without subsidies, it's a negative number, okay? At a carbon price of $50 a ton. So now there are carbon markets. They're still immature, but they're getting more and more mature, and the prices are going up steadily. And the World Bank and IMF are projecting that the price of a carbon capture of a ton of CO2 equivalent will be $100 by 2030. Well, at $50 a ton of carbon capture, you can actually, using satellite data and stuff like that, estimate the carbon capture potential, high resolution of land in the US. That's what this map is. The average acre of land that's used for cattle in the US could earn $30 per acre per year for the next 100 years by capturing carbon, by restoring the native ecosystem and making profit from carbon credits. And that would also be the critical thing for reversing the collapse of global biodiversity. So I think that this is going to actually, ironically, be another driver of the demise of animal agriculture, the farmers and ranchers. Okay. So that's why I believe that animal agriculture is going to be gone in 20 years. Happy to debate that with anyone later. I'm sure there'll be plenty of skeptics. And the world will be better for your kids and grandkids, and future generations, and you'll still have meat.